All right, so we're going to take a little bit of time and review factoring quadratic expressions. And then that will lead us next week into a way of solving quadratic equations using factoring. So we talked about two different methods for factoring. And with either method, the first thing we want to do is check to see if we have a greatest common factor. If we do, factor it out. If we don't, then we go to this next step where we just determine which method we're going to use. And there are more than these two methods. We just focused on two because they work really well. So if a, the value in front of x squared, is 1, or there just isn't a number written there, we can use the x method, where we look for two numbers that multiply to c and add to b. In this case, both numbers are negative, so we have to have both b and c are negative. So we have to have numbers that multiply to a negative number. That means we have to have one positive and one negative factor. And then they add to a negative number. So the larger factor has to be the one that has the negative with it. Excuse me. And then you try some values. And my advice is always, if you're not sure, start with 1 in the number. If I add those together, I get negative 15, so that's not the right pair because they don't add to negative 6. Then try 2 if it's a factor. And let's see, negative 16 divided by 2 is negative 8. And 2 plus negative 8 is negative 6. So those are my two factors, x plus 2, x minus 8. And this is the answer. That is the factored form. In terms of things that we've seen like this would be our intercept form for graphing a quadratic. So that's if a is 1. If a is not 1, so here we have a is 5. Again, we check for a greatest common factor. There isn't one. So we use the slide method. Take the 5, slide it across, and multiply. The first two terms then, we just remove the 5. So we have x squared plus 7x, and negative 6 times positive 5 is negative 30. And now it is very much in the form that we could use our x method with. So now we're going to look for two numbers that multiply to negative 30 and add to positive 7. So again, multiply to a negative. So we have to have one positive and one negative factor, but it adds to a positive. So the positive factor has to be larger this time. So again, starting with negative 1 and 30, that doesn't add to 7. Negative 2 and 15, that doesn't add to 7. Negative 3 and 10, that does add to 7. So I have x minus 3 and x plus 10. However, to get that answer, I had to multiply by 5. So now to get my final answer, I divide both of these by 5. Does 5 divide evenly into 3? No, we don't get an integer value. Is there a number that divides evenly into both 3 and 5 other than 1? No, because actually they're both prime. So we reduce this fraction as much as we can. And if we still have a fraction left over, the denominator goes in front of the x. 10 divided by 5, that's 2. So if it divides evenly, we write the quotient as our second factor. All right, so that's just a quick review. There are a couple of special cases as well that we're going to talk about. One is the difference of two squares. So if we have two terms, this is the key, there are only two terms here, and we're subtracting. In order to use a difference of two squares, both the first term and the second term, or the last term, have to be perfect squares. And they would factor into a plus b and a minus b. So looking at this, is 4 a perfect square? Yes, it's 2 squared. Is 49 a perfect square? Yes, it's 7 squared. So we would get 2x plus 7 and 2x minus 7. Excuse me. The second special case, actually, if you use the other methods that we learned, they still work for this special case, the perfect square trinomial. Otherwise, you have to recognize kind of a difficult pattern. A squared plus 2ab plus b squared. It does factor. In this case, we would get a plus b, the quantity squared. If you don't recognize it, you can factor it the other way. And if you get the exact same factors, you can write it as it's called a binomial squared, or the square of a binomial. And the example here, we have x squared plus 2 times 4 times x plus 4 squared. So it's x plus 4, the quantity squared. Again, I usually don't even worry about if I recognize a perfect square trinomial. I'll usually use the x method or the slide method to factor. All right. Factor each expression completely. Remember to check for a GCF first. So if there is not a number in front of our first term, we don't have to worry about a number being our GCF, but we should check to see if we have variables in every term. In this case, we do not have a variable in all three terms, so there's not going to be a GCF. The GCF is 1, and we don't have to worry about it. In front of the x squared, we have a 1, so we can use the x method. Two numbers that multiply to negative 42 and add to positive 1. So multiply to a negative, so we have to have one positive value, one negative value, and the larger value has to be positive, the larger factor. So again, we can start with negative 1 and 42. That doesn't add to 1, although I am always amazed at the number of students that put that as their answer because they see the 1 here in the middle. Negative 2 and 21 doesn't add to 1. Negative 3 and 14, but that doesn't add to 1. 4 is not going to be a factor. 5 is not going to be a factor because 42 doesn't end in 0 or 5. 6 will be a factor because both 2 and 3 are factors. So negative 6, positive 7, and that does add to 1. And there's our answer. All right, next example. 3x cubed plus 24x squared plus 48x. So the first thing I'm going to do is check, is there a greatest common factor, a number that evenly divides into 3, 24, and 48? The answer, yes. They are all evenly divisible by 3. And then I also look, I have x cubed, x squared, and x. So remember that smallest exponent with x, if I have x's in all 3 terms, becomes a greatest common factor. Factoring that out means basically you're dividing. 3 divided by 3 is 1. I had x cubed. I took away one of the x's. It leaves me with x squared. 24 divided by 3 is 8. I had x squared. I factored out an x. So I'm left with x, or x to the first. 48 divided by 3 is 16. I had an x, but I factored it out. There are no x's in my last term. We have actually, I think, factored that already today, but I will do it again. It looks like an x method. Multiply to 16, add to 8. Both are positive, so both of my factors are positive. 1 and 16 doesn't add to 8. 2 and 8, but they don't add to 8. 3 is not a factor. 4 and 4 does add to 8. So our factored form would be 3x times x plus 4 times x plus 4, or 3x times x plus 4 squared. Either one of these two is correct because they actually mean the same thing. All right, check for a greatest common factor first. So is there a number other than 1 that divides evenly into 2, 9, and 4? And I don't, not a number other than 1. So that's not going to have a greatest common factor. And it doesn't have x's in all 3 terms. So this is going to be a slide rule. Slide the 2 over and multiply. Now we can use the x method, 2 numbers that multiply to 8 and add to 9. Let's see, 1 and 8 multiply to 8, and they add to 9. That's perfect. So I get x plus 1, x plus 8. But to get those factors, I ended up multiplying by 2. So I need to divide by 2. 1 divided by 2, that does not come out as an integer. And there is not a number other than 1 that evenly divides into both. So that means my denominator goes up in front of the x as one of my factors. So 2x plus 1 is a factor. 8 divided by 2 is 4. So that one, we just put x plus 4. And that's my, my factored pair, or my factored form. All right, 4x squared minus 28x plus 49. Again, check, Is there a variable in each? No, so there's not a variable for greatest common factor. Are each of these numbers evenly divisible by the same thing? The only numbers that divide into 4 are 2 and 4. 49 is not divisible by 2 because it's not even, and it's not divisible by 4. So again, there's no greatest common factor. This one actually is one of our special cases. It is a perfect square trinomial. If you didn't recognize that, you can use the slide method. Take the 4, slide it over. Now notice you get that very big number, 196. And then they have to add to negative 28. So they're both going to be negative. So -1, negative 196. That doesn't add to negative 28. -2 and negative 98. That doesn't add to 28, negative 28. 3, if I add the digits, I get 16. That's not evenly divisible by 3, so 3 is not a factor. 4, I know, is a factor, basically because I got that by multiplying 4 and 49, but they don't add to 28. 5 is not a factor because 196 does not end in a 0 or a 5. 6 is not a factor because 3 is not a factor. 7 is just one we have to check. And 7 goes in there 28 times. That doesn't add to negative 28, but we're getting pretty close. That adds to negative 35. We're pretty close. 8 is not a factor. I know that because even though 4 is a factor, the other factor is not even, so 8 is not going to work. Nine, well, if I add up the digits, they add to 16. 16 is not evenly divisible by 9, so that's not a factor. 10 is not a factor because the last digit is not 0. 11 doesn't work. 12. 12 will not work because 3 is not a factor. 13, again, 13 you just have to try, and sometimes having a calculator handy helps a lot. But 13 does not work. 14 does. And that adds to negative 28. So not a lot of factor pairs, but we had to go to a lot of numbers to get to our factor pair. So this would be x squared minus 14, x squared minus 14, and you can see that we have the same factors, but to get those factors, we ended up multiplying by 4. So we need to divide by 4. I shouldn't have put the x squareds. It should have just been x. Sorry about that. There is a number that divides evenly into both 14 and 4. It's 2. And then the 2 that's in the denominator moves up in front of the x. And so you can see that even if we didn't recognize that special pattern, we can get the correct answer. It takes a little bit longer, but we can get it. All right, again, factor out the greatest common factor first. Is there a number that evenly divides into 18 and 32? 2 divides evenly into both. So 2 is going to be part of my greatest common factor. They also both have x's, and x squared is the smallest exponent. So I'm going to take that out. 18 divided by 2 is 9. I had x to the fourth. I took away 2 of the x's, leaves me with x squared. 32 divided by 2 is 16. I had x squared. I factored it out. 2 terms and a subtraction in between leads me to believe these are perfect squares. 9 is 3 squared. 16 is 4 squared. So this does end up being a difference of squares, or a difference of perfect squares. And there's our factor. Don't forget the 2x squared, the GCF does go out front. All right. 8x squared plus 8x minus 30. Is there a GCF? All those numbers are even, so there's for sure a 2. This is not going to be one of my special cases, because for it to be a difference of squares, we have to have only 2 terms. If it's a perfect square trinomial, the last term has to be plus. So, excuse me. So those don't meet those criteria. So we will use the slide method. Take the 4, slide it across and multiply. Find 2 numbers that multiply to -60, add to +4. So we are going to have a positive and a negative factor. And the larger factor in this case has to be positive because we're adding 4x. So -1 and 60. That doesn't add to 4. -2 and 30. That doesn't add to 4. -3 and 20. That doesn't add to 4. -4 and 15. That doesn't add to 4. -5 and 12. That doesn't add to 4. -6 and 10. That does add to 4. So that's our pair. To get those, I multiplied by 4. So now I'm going to divide by 4. In this first pair, that fraction reduces. There's a common factor of 2. Same thing with this second pair. So reduce those fractions, otherwise you're not going to get the correct answer. And then we bring the 2 up front. And we get our factored answer, our final answer in factored form. All right, I am going to give you a few minutes to try a couple, and then we'll check answers in, let's say, 3 minutes. If I can get the timer to work. All right. So this first one, again, there's that subtraction. So, and only two terms. So I would immediately think, boy, is that a difference of two squares? 9 is a perfect square. It is 3 times 3. 100 is 10 times 10. Yeah, perfect. Right. If you did not recognize that, you could still use the slide method. It just takes a little bit of time. And in this case, you would find two numbers that multiply to negative 900 and add to 0 because we don't have a term with just x. So it could happen. It just takes a little bit of time. The second one, is there a greatest common factor? And I guess I should have checked for the first one, but there wasn't a greatest common factor. 6 is evenly divisible by 2, 3, and 6, but none of the other two numbers, neither of the other two numbers, easy for me to say, are divisible by 2, 3, or 6. So this is going to be a slide method. Two numbers that multiply to negative 30, add to negative 7. So we know we're going to have a positive number and a negative number for our factors, and the negative factor has to be larger. So 1 and negative 30 doesn't add to negative 7. 2 and negative 15 doesn't add to negative 7. 3 and negative 10 does add to negative 7. That's our pair, 3 and minus 10. So x plus 3, x minus 10. Again, to get that, though, we had to multiply by 6. So now we divide by 6 and reduce our fractions. 3 over 6 is 1/2. 3 divides into both. 10 over 6, a 2 is a common factor. We get 5 over 3. If I divided 1 over 2, I wouldn't get an integer. I get 0.5. So that's not going to happen. We take our 2, we write it out in front of the x, 2x plus 1. 5 divided by 3 is 1.67 repeating, so that's not a whole number. So we take the 3, write it in front of the x, and we have that factor. Again, if you finish and you say, boy, is that really the right answer? You could multiply these out using either the box method or FOIL and check your work. Don't be afraid to do that. That's actually a very good idea. So, you can always check your answers and make sure you've got everything correct. That's it for material today. The assignment and the note check are already active in Schoology, so they are there for you to go ahead and work on. Also, take a look at any missing work from 8.4 to 8.6. It has been marked missing. I would suggest going into Schoology and looking at your grades, and then clicking on intermediate algebra and seeing anything missing, you can still turn in. If it's just a 0, that means that if it was from 8.1 to 8.3, that's cut off. You can't turn those in anymore. All of your missing work from 8.4 through 8.6 will be due next Wednesday at the end of the day. So make sure if you have anything missing, get that done. All right. Any questions?